purpose of this video is to think about this concept of the word probability and how it is interpreted differently depending on whether one is a frequentist or a Bayesian. And so we will begin with this question. What is the probability that the Edmonton Oilers are going to make it to the playoffs? And we can ask ourselves how the frequentist and the Bayesians might respond to this question. It's not really a matter of how they would attempt to answer this. It's really a matter of, does this question have meaning? Is this a meaningful question, or is it just gibberish? And what a frequentist would say is that this question is actually just nonsense. It's a category error. It's equivalent to asking, how does the number 17 taste? Now, why would a frequentist feel that way? Well, the reason a frequentist would feel that way is that a frequentist defines this term probability in terms of frequencies. And if one cannot come up with a scenario in which probability is thought of as being a frequency, then that word probability cannot be applied. Let's think of a couple of examples. And our first example is where we've got these species and these height classes, and we can think about this height class here being the small trees, height less than 170 centimeters. So we've got the probability of a tree being small, we're stating is equal to 0.55. So what does that 0.55 really mean? What it means is, or the way we can think about it, is if this is our underlying population, we could go into that underlying population and randomly take a sample of 100 trees, and we could determine that the proportion of trees in that sample that were small might be equal to 0.67. And then we could take another sample and determine that the proportion of small trees was 0.43. We could continue this many times. We could take the average of all those samples. As the number of samples approaches infinity, the average of all those proportions is going to approach 0.55. So in this example, we can think of what this word probability means, and we're thinking about it in terms of a long-term frequency of outcomes when you're taking a very large number of samples from a population. Here's another example, a second example. Let's say we've got a fair coin, and we say that the probability of getting ahead is 0.5. What does the frequentist think that means? Well, in the frequentist view, what that probability of getting ahead 0.5 means is if we took our coin and flipped it many times, as the number of flips approaches infinity, then the proportion of heads is going to approach 0.5. So once again, we're thinking about probability. This word probability is a reflection of, in the mind of the frequentist, long-term frequencies, long-run frequencies of some sort of physical event, in this case, the flipping of a coin. Now we can see why the frequentist looks at this question and just rolls their eyes. Because we cannot take this question and cast it in terms of any sort of long-run frequency of samples. In this case, we had a population from which we drew many samples. There is only one playing season 2022. We cannot draw multiple samples from that one season. When it comes to the year 2022, either one of two things is going to happen. Either Edmonton is going to make the playoffs or they're not going to make the playoffs. There's no way we can view this question in a way that invokes frequency, long-run frequencies of a physical event, and therefore it's nonsense from the frequentist view of what the word probability really means. The Bayesian, on the other hand, is not going to be troubled by that question, because when the Bayesian thinks of probability, they're thinking it in terms of beliefs. And so if you look at the standard that we'll see over and over again equation for Bayesian data analysis, the Bayesian begins with some prior beliefs, collects some data, adjusts those prior beliefs to come up with some posterior beliefs. So the Bayesian is not troubled by this question. The Bayesian says, if I view probability as meaning my belief, I believe that the probability of the Oilers making the playoffs is 0.2. And better yet, if I consider that odds are equal to probability over 1 minus probability, I've got 0.2 over 0.8, and that turns out to be 4-to-1 odds. So the Bayesian's laughing. Not only can they answer the question with this view of probability, they can actually get an answer that enables them to run off to their favorite gambling platform and lay down a bet. So that's one way of looking at the difference between Bayesian and frequentist interpretations. I want to go through now another example. And it comes back to this idea, the question of what proportion of people in the world are right-handed. And what the frequentist says is, okay, yeah, I can kind of see your point, little Bayesian. Bayesian's kind of got this advantage that he can answer questions like this that are interesting. On the other hand, the frequentist is going to say that there's a big problem with this interpretation of the meaning of the word probability, and we can see it in this example. So if we ask ourselves, what proportion of the people in the world are right-handed? What the frequentist is going to say to the Bayesian is that the Bayesian had a prior distribution for the proportion of the people that are right-handed. So here's the different possible proportions of the people that are right-handed. And the Bayesian had a prior distribution, and after getting some data, came up with a posterior distribution. And the frequentist is going to say that is completely wrong-headed. The frequentist is going to say you simply can't think that way. And the basis for the frequentist's argument is that this thing here, the proportion of the people in the world that are right-handed, is not a random variable. It is a single fixed number. And so what the frequentist is saying to the Bayesian is, look, Bayesian, how dare you? How dare you attach a probability distribution? Those are the possible values of the proportion that are right-handed. how can you attach a probability distribution to what really is a single number? And if we had enough dollars, we could go out there and we could ask every person on the planet whether or not they're right-handed. So this is a single value. It's not a random variable. And so the Bayesian, or excuse me, the frequentist is going to say to the Bayesian to attach a probability distribution to a single value is wrong thinking. But the Bayesian will respond. The Bayesian will respond is, you got to remember what I, as a Bayesian, mean when I'm thinking about probability. I, the Bayesian, when I think of probability, I'm thinking about my beliefs. I, the Bayesian, I'll grant you, little frequentist, I'll grant you that this is correct. The proportion of people on the earth who are right-handed is a single fixed number. I agree with that. But here's the thing. My interpretation of the word probability is not related to some long-run frequency of some physical event. My interpretation of the word probability is based on beliefs. So I had some prior beliefs. Like this. This distribution is a reflection of my uncertainty. I agree, the Bayesian says to the frequentist, that you're correct in saying that there's a fixed number of people on planet Earth who are right-handed. But, continues the Bayesian, I do not know what that value is, but I can characterize my beliefs by a prior and later a posterior distribution. So in many ways, what I find most fascinating about this is if you think about statistics is based on math, and if there's anything in this universe that's objective, it's math. And yet at the same time, we've got the fundamental concept that's so central to all of statistics, this word probability, and we've got two very distinct views as to what that word actually means.